second, and then at I it stops. So it's just obeying what I have here, where there's friction, it slows down. When it's going up a ramp, it slows down. Going down a ramp, it speeds up. Friction, it slows down. Up a ramp, it slows down. Acceleration and change in velocity are the same sign. And again, that's change in velocity. From A to B, what is the change in velocity?
5 meters per second? 5 meters per second?
Negative. The negative critical here. Negative 5. From B to C.
0 meters per second.
From C to D.
Negative 15 meters per second.
D to E.
Positive? Oh wait, it's negative. Negative 15.
It's still negative 15. It's speeding up, yes, so it's going from 0 to something not 0, but the velocity is a negative change. It's negative 15 minus 0. All right, from E to F.
0 meters per second.
F to G.
Positive 5.
I heard positive 5. G to H.
Positive 5.
H to I.
Positive 5.
So, from A to B, negative. A to B, negative. Then 0, then it's negative, going up and back. So from C, this is negative here. And then it's 0 again. And then it's positive from F onwards. Positive change, positive change, positive change.
Okay.
Positives across the board.
Will you include the numbers like that on the test? Because that's a
No.
that's a really easy way to kind of do that.
But you are welcome to do that. I've only done this a couple times, but students didn't, it's the last problem of the test, so you're either feeling good or not. I guess you could get that neutral feeling. I rarely had a neutral feeling on the test. It was feeling good or feeling horrible. And I projected that onto you, I apologize.
But we could come up with the numbers ourselves,
Absolutely.
and then that'd be a good way to check our answers.
Yes, I completely agree with that.
Okay.
All right. Any other questions at the moment? All right, let's just do a simple little problem here. We've got 5 minutes to go. I see some people feeling like we're over, but it's not done yet. Getting better. We're not going to actually do numbers. The ball is dropped. Near Earth. It falls for 3 seconds. How far does it fall? How fast is it going? After the 3 seconds.
And you've given us enough information to answer the question.
Yes, I have. I do want to throw in ignore air resistance, which will be a common theme throughout the course. He does get into a little bit of air resistance, but only briefly. Usually we throw it out, which is the classic approach to teaching physics is you start with a nice ideal situation, sometimes referred to as consider a spherical cow, and then you slowly add reality in the farther you go in physics. So we will consider a nice air resistance free zone. All right, so let's pull out what information that we have here. There are two pieces of information, actually three pieces of information that are given in this sentence right here, or in those sentences. What are the three pieces of information that we have?
Dropped, falls, earth, so we know it's gravity is going down.
All right, so the fact that it's a ball is irrelevant in terms of the problem. Since we're ignoring the air resistance, it could have been anything.
And
We got drop.
All right, what does drop mean in terms of numbers?
Negative.
Sorry.
Downward.
That means it's gonna go downwards, but there's a more critical piece of information there.
Speeding up.
It starts at 0.
What starts at 0?
The ball's velocity.
Yeah. Dropping is, we know that the initial velocity is 0. If the initial velocity is not 0, then we would have used a verb like thrown,
Okay.
projected, propelled. Dropped is it's starting at rest. All right, so that's dropped. Somebody mentioned Earth. If
Yeah.
you're near the surface of a large planet, acceleration is is close to a constant, is not really a constant, but we pretend. If you are designing work for NASA, don't make this assumption. Now, depends upon the planet or the moon or the very large object, but Earth tells us that G is approximately 9.8 meters per second squared. That's the acceleration due to gravity. The lowercase g, this is the symbol for acceleration due to gravity. Acceleration due to gravity is always a positive number. There's no vector symbol over this. Now, if you want to make down positive, that's fine. If you want to make down negative, that's fine. But g itself, this lowercase g, is always going to be a positive number. And then one other piece of information, I didn't think I heard anybody say it, but quite possibly someone did. Yeah, that's the other one. Time is 3 seconds. So we can figure out how fast it's going. That's going to be probably the simpler one. And I'm just going to shove this one through. Acceleration is the change in velocity or a change in time. In our particular case, that's g is equal to v final minus v initial over time. So we have 9.8 is equal to my final velocity, which is what is being asked. I guess I say how fast, so I'm looking for a speed, but if I find the velocity, I'll just get the absolute value of it. Minus 0 divided by 3. This is the math problem. If having all the vector symbol and the subscript are messing you up, we can just change it. That's the math problem, the essence of it, because I'm subtracting 0 from it. And then to solve for v, cross multiply or multiply both sides by 3, however you want to look at it.
That's a good one.
Leave it. Thank you very much. You as well.
So this goes 29.4 meters per second.
How about the actually was you gonna be, added now, or multiplying that?
Say it again?
Multiplying the 99.8 times 3?
Times 3?
Yeah.
How did I know to do that?
No, I was wondering if you, multiplied it, but. I
Oh,
see.
yeah, I multiplied those. Now, if I had chosen, so technically, that is my velocity. Because my acceleration written here is positive, that means that is telling me that I made down positive. If I had made up positive, then this would be a negative here. And that would be negative 29.4 meters per second. And negative just means it's going in the negative direction. The question actually asked for how fast, implying a speed, and so the actual answer is 29.4 meters per second. How far does it fall? Well, that one I guess will be a cliffhanger. So, think. Oh, Bryson says we did it 2 minutes ago. Have a nice week. Stay safe, please.
You too.
And stay away from knuckleheads. Because they're the people who get eaten by bears. Thank you.